Ohayou gozaimasu. Watashi wa David desu. Yoroshiku onegai shimasu. Nihongo wo hanasemasen. So no tame eigo de hanashimasu. Hello everyone, my name is David and I'm very happy to be here to talk about game engine. So today I will talk about video games. What's the core concept of a game engine? How to display things on the screen? How to play awesome? And can you do search things with Kotlin and Kotlin Multiplatform? But first, I want to ask you one very simple question. Who in this room do know this game? Okay, great. It seems that this game is also popular here. But let's see how such game is working. So the first concept is how to manage a game loop. So in a game, you need to manage different kind of entities. For example, here there's the player, the blue box. But you have to manage also different kind of entities. For example, here in red, some platforms, in yellow, some coins. As a game is an interactive experience, the player may push a button. And for example, when he pushes the button, the player will jump. If he touch a coin, you need to manage that. For example, to change the score, to make the coins disappear, and so on. Once it's done, you have to render everything on screen. So you can get a visual representation of your game, and this final result will be a frame. How is it working in terms of code? Actually, just a method. And in this method, you will manage entities. You will move the player, you will move some enemies, you will move some elements of the world. Then you will render the world. So you render the background, you will render enemies, coins, the player, and so on. And you will do that 60 times per second, so you can create the illusion of movement. So now you do know the core mechanism of a game with a game loop. Let's check now what is Kotlin Multiplatform. The core concept of Kotlin Multiplatform is simple. You have a common source set. In this source set, you can put a code that is not specific to any platform. For example, you want to use the big integer, you will not be able to use it in this source set. Instead, you have to define different kind of source set. For example, one for Android, one for the JVM, and so on. You have to create one source set for every platform you want to target. And obviously, in the JVM source set, you will be able this time to access the big integer class. You might notice that with Kotlin Multiplatform, you can target Android, iOS, but not only. You can also target different kind of platform like the JVM and, as I said, the web platform with JavaScript, so your code can run in a browser. To manage specific code to a platform, the recommended way is to create an interface in the common source set, then to create an implementation of this interface in the dedicated source set. So for example, here in the JVM source set, you will create the JVM implementation. And here, because I'm in the JVM source set, I will be able to access a JVM library to check, for example, if the player push a button or whatsoever. Same thing for the web platform. You can create a JS implementation of the interface, and here you will be able to access the browser API to check if the player touch the screen or just push a button. In each source set, you can pass the specific implementation, for example, to a consumer that is only in the common source set. For here, for example, the Engin class. As the consumer is using only the interface we saw before, it will not know the implementation used. But there is another way to achieve the same result. You can define a factory method in the common source set, and you will add the modifier expect. The modifier expect actually is tell to the compiler that it needs to check in every different kind of source set that there is the same implementation of a method. And obviously, in each source set, this time you will be able to return the implementation dedicated to your source set. So to create my game engine, I try a very naive approach. So the idea was to use a different kind of game engine per platform. So for example, on Android and on the JVM, and try to use libgdx. On the web platform, I try to use playcanvas. Playcanvas is a JavaScript game framework. And to try the native implementation, to try the native support instead, I try Relib. And actually, it's working. But you may notice that the rendering is not exactly the same on every platform. The other issue is the API. Engines are so different, it's very hard to create a common API over the top of different game engines. So I tried something else. Instead, I try to use OpenGL. OpenGL, it's an API for rendering 2D and 3D graphics, and actually it's multi-platform. What I mean is that it's available on different platforms, like on Android with OpenGL ES. ES stands for Embedded System. It's available on the JVM by, you need to use a library to use it, but you still can do it. Or it's also available on the web platform with WebGL. So let's take a deeper look into OpenGL. How is it working? So the core mechanism of OpenGL is to use a pipeline of shaders. First, you have the vertex shader, in which you can manipulate the position of the components of your 3D model. Then you have the fragment shader, in which you can manage here the colors. But what is a shader? Actually, a shader is just a piece of code that will be executed on the GPU. Here, this is just a simple example of shader for OpenGL. It's in GLSL, OpenGL shading language. But I'm talking about shaders. Let's see a real-world example, but this time with the game Doom. So to render a single frame in this game, actually there is multiple shaders that will be executed. So here this is a frame of the game, but without any effect. Then they will compute another frame. Here the normal map, a deep map, the specular map. They will mix everything and you will get a new frame with few effects. After, they will apply a tonality, so you can get the red color here. They will add the user interface, and voila, you get the final frame of your game. What I want to show you here is that modern games are using a lot of shaders, and creating such shaders is not an easy task. It's a lot of work. If you want more information about how it's working for Doom, I advise you to check this blog by Adrian Courage. It's a lot of details on how shaders are working in this game or other games. But let's go back to Kotlin. Let's try to draw our first object on the screen. So on the JVM, I will use WebGL. So thanks to this library, I can access OpenGL. Don't try to remember this code. What is important to understand is that to get your first frame, you need to configure few things first. Once it's done, you can access to the game loop. Here, it's only just a while, so it's quite easy. So I said you need to configure few things. Actually, the real code, it's a bit more long. You have more things to configure. To be fair, it's long, but it's very simple. You just need to check the documentation, and regarding what you want to do, it's easy to configure. But what is interesting is to compare this version with the WebGL version. As you may notice, it's way more short. To render a frame, here you just need to access a standard method in JavaScript, which is here request animation frame. And Android, it's a bit different, but it's very easy also. You just need to instantiate the GL surface view object and to redefine a method so you can access to a famous game loop. So actually, in 3D, you're not rendering one object right away. Actually, what you're doing instead, if you render triangles. So let's check how to render at least one triangle on the screen. So the idea is to send coordinates of send coordinates to OpenGL using a buffer. Then you will assign this buffer to one attribute of this shader, and after you can say to OpenGL, draw it on the screen. What I mean by assigning an attribute to a shader, here we can see I'm using the name position. It means that in my shader I will be access the data from this attribute in my shader with the name position. Here, the shader is just doing nothing. It's taking coordinates and it's passing it to OpenGL. But if I want, I can create another shader that will alter some position of my model. If you're doing everything correctly, you will be able to get your first model on the screen. And here we can see it's already using Kotlin Multiplatform. So the model is displayed on the JVM, but also in my web browser and on a mobile device. You may notice that before we can see the head moving a bit. To do such animation, I use matrices. Matrices is a powerful tool to transform objects in a 3D space. So, but think as a matrix like just a mathematical way to represent and manipulate object position, rotation, or scale in a 3D environment. So a matrix can hold different kind of data, like a translation, if you want to move an object, but also rotation, to turn an object, and the last one is the scale, so if you want to make an object smaller or bigger. And what is very interesting with matrix is that you can do mathematical operation with it. So another example, here we have one model. If I want to move it, I will just multiply the identity matrix by a translation matrix and it will move the model. If I'm doing it again with another translation matrix, it will move the model again, and so on. So if I'm using this time a rotation matrix, this time it will turn the model. To do that, I'm using Kotlin Map. Kotlin Map is a Kotlin library that can be used with Kotlin Multiplatform. Thanks to Kotlin, here I can use operator like times. I can redefine a search operator. And so I can do complex matrix computation, but as a single mathematical operation. So for example, the example we saw before, I can do it again in Kotlin, and it's quite easy. I just need to multiply one matrix by another. But what can I do with matrices? You can do more complicated things. Maybe you already saw this kind of animation before with a skeleton. Actually, the skeleton here is used to animate the model. At first, I thought it was very complicated to create such things, but thanks to matrices, not that much. So the idea is you have a bone and you will assign some vertices to this bone as a group of vertices. You can do that with another bone. And so it will create the reference position. Most of the time, we call that the T position. Maybe you already saw it also. It's when the character is in T pose like that. So to move part of the model, you need to compute the transformation to reach this new position. It will give you a matrix. So you move the bone, you compute the transformation to this bone, and thanks to this transformation, actually what you do is you will apply it to every vertices of the group assigned to your bone, and it will move it. And so you can get such cool animation. Please don't mind the quality of the 3D model. I did it myself, and I'm not very good to do 3D model. So because it's a lot of computation, actually one part is done on the CPU with Kotlin Multiplatform. What I did is to create the position reference with matrices, as you can see before. But the rest, like changing the vertex position, is done in a shader. So this example, it's perfect to remind you that it's not because you're using Kotlin Multiplatform and OpenGL, which is a multi-platform API, that everything will work the same way on every platform and on every device. The same animation before, here it's on my TV, on Android TV. As you may notice, it's not the same at all. I fixed the issue. To do that, I just add an empty if, just doing nothing. Don't ask me why it's fixed the issue, but I can tell you only one thing: it was not easy to find. That adding an empty if will fix everything. So I talked about Android, the web platform, but I didn't talk about iOS yet. So what about iOS? Actually, iOS platform is another beast. First, it's obvious, but you need a Mac to compile to use the iOS toolchain, which is very specific. If you need the iOS toolchain, it means you also need Xcode. And for me, I'm very fan on IntelliJ and Android Studio using Xcode. It's a bit complicated, so I'm very happy that JetBrains released a plugin. And I advise you to install it if you want to do Kotlin Multiplatform with iOS. So you can run your application right away from IntelliJ and to start your application on the iPhone simulator without any issue. There is also a new method that you can access from the iOS source set. So here is the method usePin. It allows you, for example, to pass to native method the address on a variable. It's very useful, but again, something like that for me, it's a bit hard to use because I'm doing Kotlin every day. The last time I did some C programming was like 20 years ago. So it's a bit hard for me to remember reflexes about pointer manipulation. But at least you do know you can call native method on the iOS platform. So I adjust my game engine to work on iOS. Here is the result. Just a cube turning around. It might be a bit disappointing, but actually, when I try to push a bit more far my game engine on the iOS platform, it was a bit complicated. The application only keep crashing, and by meaning keep crashing, it's a big crash. Like the application stopped working and there's no logs, no way to find why it's not working. And so it's very also complicated to find any help on this topic. So I check again the documentation. As you may see, OpenGL on iOS is deprecated. Instead, they advise to use Metal. Metal is another graphic API, but available on iOS. The issue with Metal is that if you do 3D things, you need to write shaders. It's working a bit like OpenGL, but the shaders is not at all the same than with OpenGL, which means that if I want to adjust my game engine to use Metal, I need to use Metal API, but I also need to rewrite all my shaders. And there's a lot of shaders in my game engine. So to be honest, I stopped pushing a bit too much my 3D game engine. But there is also another reason. It's not only a graphic API, because actually 3D is not easy. You need to be good at modeling, which is not my case. You need to manage lighting, which is not an easy issue. You have to manage different things in a game engine, like the level of detail. If something is very close to you, you want to draw a lot of triangles. If it's very far, you want few triangles. But to do that, you have to create the model again, but with less triangles. It's a lot of work. You have to manage different things like perspective camera, orthographic camera, or the collision management. In a 3D space, collision management is quite complicated also. You need to find some algorithm and being applied in your game engine. So at the end, my 3D game engine, I'm quite happy with the result. For example, here we can see a character dancing in my web browser. I was able to create some few games with it. But I was not satisfied. I wanted a game engine in which I can create a game very quickly. So I try again, but this time in 2D, because I was pretty sure it will be easier to create. And again, I use a very native approach. So this time, I will draw just a plane on the screen, a very simple plane. And I will put an image, I will draw an image in this plane. I will update this image, and I will update it again on my plane. And so on and so on. It will create the animation. In terms of OpenGL pipeline, here it's very simple. I have one vertex shader, it's just draw a plane on the screen. And the fragment shader will just draw the picture on this plane. So the idea is, let the command source code generate images. Then after I will pass this image to the graphic layer, and I will display it on the screen using the dedicated graphic API. So here, for example, on Android, OpenGL, JS, WebGL, and iOS, it's going to be Metal. The good things with this approach is that actually, if I'm able to draw just a plane on the screen to put a texture in it, it's easy to use. I just need to find an API that can do that. So if I want to switch API, also it's very easy. And drawing one plane with one texture, actually it's almost the hello world of every graphic API. which means that it's going to be easy for me to use any graphic API if I want. So let's take a look to frame generation. So actually, a picture is just an array of colors. The internal representation is a 1D array. So in my game engine, actually, you're not using colors right away. Instead, you're using color index, which means that on the index 1, you will get here the blue color. On the index 4, you will get the yellow color. And so the programmer can set any color on any pixel. And for me, it's easier to set an index instead of the color right away. But before rendering on the screen, obviously I need to change the index by the real color. So the idea is to check to a lookup table. Okay, so the index 1 is the blue color. I will get the code for the blue color, and the same thing for other index. So actually, my 2D game engine is just filling one array with indexes to get the final color rendered. And to do this kind of picture, to manipulate this kind of array, I didn't use Kotlin actually. I use Lua. Lua is quite famous in the game development community, and it's very easy to learn. So here is just an example of what you can do in Lua. You can declare function. The fun thing is that array, they didn't start at 0 here, but to 1. And you can declare a variable very easily. There is no type. You don't have to set the type, in the code. You can declare literals, you can declare array, dictionary, and things like that. So to do that, I use Conjure Luac, and actually this presentation, it's an opportunity for me to thank the Conj project, because what we did is to port the Java libraries that support Lua in Kotlin and Kotlin Multiplatform. And thanks to that, my game engine is not the same, and it's working very well thanks to it. So all this library is working. So the good thing is that from Kotlin, from my game engine, I can call a game script. But it's working also the opposite way, which means that from Lua, I can call some Kotlin. So what I did is to create some game libraries that can be called from Lua. So I can almost define my own API that people will be able to use in Lua. I create different kind of libraries. So one for drawing sprite on the screen, another one to check the player input, and also some to generate sound. Here we can see some primitives I created. So if you want to draw a line, you just need to call the method shape.line. You can draw a fill rectangle, but you can also draw a sprite on the screen. You can do a bit more complicated things thanks to this kind of API. And to be honest, for me it was easy, for example, to create this kind of animation. It took me less than 20 minutes. You write the code, you save, the game engine reload automatically the code, and it's really easy to get this kind of cool animation. Obviously, you can do other things like checking the player input. So here, with this small script, I'm just moving the sprite on the screen. And if you're pushing things more far, you can create, obviously, games. So here, this is some example of game I created using my game engine. Some games were created in less than 3 hours, some in a weekend, some in few weeks, but every game in less than 1 month, because it was very easy to create games with my game engine. So for the sound part, I use a special approach, because I could just play some audio file. It's quite easy to do, but the issue is to generate an audio file, to create an audio file is not an easy thing. You need to record things, or you need to download, for example, sound on the internet, but the sound will not be consistent in your game. What I want is to create a consistent experience. So, and I want something easy to create. I want something to be, it should be easy to create some sound or music. So what I did is I use MIDI, which stands for Musical Instrument Digital Interface. What's the concept of MIDI? You have some instrument, and actually it will not generate sound. Instead, it will generate some data that can be sent to a synthesizer. Because it's data, actually you can also read a file that contains a lot of data. And this is what I did in my game engine. I'm not using an instrument, I'm just reading a file. And this is the synthesizer that will generate the sound. The good things and the bad thing at the same time is that if you're using a different synthesizer, the sound will be different. It might be abstract like that, but let's take an example. So let's see this word. I do believe that in Japanese you will say that baguetto, but actually in French it's baguette. My point is that this is the same word, the same letters, but it will sound different for language. So it's the same thing in MIDI, which means that, for example, in my browser it will sound this way, but on another browser, another device, it will sound something else. And because I wanted consistent experience across all the device, I use another approach. This time, I generate myself the sound. So, what is a sound? Actually, a sound is just a waveform, and you can transform this kind of waveform. For example, you can change the amplitude to change the volume, but you can also change the frequency to get a higher pitch or to get a lower pitch one. There is different kind of waveform, the sine, the square, triangles. Actually, the sine sound will give you a more round sound, while square and triangles it will generate a more sharp sound. Technically, a waveform is just a sequence of the values between 1 and -1. So to represent a sound, actually you need an infinite value, which is obviously not possible. So instead, you will take one value every time to generate your waveform, and we call that sampling. In terms of code, to generate only one sample, actually it's quite simple. For here example, I'm using the sinus method to generate one sample at a specific time. I do know that thanks to the sinus function, the value will be between 0, 1 and -1. If I want to this time generate one sample but with a square waveform, I will change a bit the code, and here we can see that the output value will always be 0.7 or -0.7. So you can easily understand that it's going to be a square waveform. So here I show you how to generate only one sample, and to generate all the sample, what you need to do is to generate the same amount of samples that you need for the duration of your sound. So it's just a loop. To play a sound, I will take here an example to use to play a sound in Kotlin.js. So it's a good opportunity to see what you can do with Kotlin.js. So there is an audio API in your browser. So what you can do is to define in Kotlin how to use this audio API. So you can define properties, methods, and so on, thanks to the keyword external. But you can also define the default JS argument without having to define what is the default argument in Kotlin. You just say, okay, output, there is a default argument. Once it's done, you can play your sound just by setting the buffer to your audio API and just play the sound. To generate transition between sound, you might want to use what we call an envelope. So I will not go in all the detail, but just keep in mind that there is different phase during a sound, and what we will do is to play with the volume during the search phase. So there is the attack phase, in which we'll try to reach the volume level. The decay phase will change the volume to lower it a bit, for example. The sustain phase, and the last one is the release phase, which is where you want to try to reach the level 0 progressively. But the idea behind it, it's again, don't remember everything, don't try to remember everything. My point is just, in a sound, what you want to do is to play with values between -1 and 1. So this is it for the sound part, but let's take a look about performances. My first try, when I start my game engine, my 2D game engine was for my lookup table was to use map. It worked very well on the JVM, but it was very disappointing in my browser. Everything was very slow. And the idea behind using a map was to, okay, you pass the index of the color will be the key in the map. Instead, I need to change that. I use an array. So this time the ID is different. The color index is the position in the array of the color palette. So what I mean, if you're using the index, color index 1, or you see in the array, this is the index 1. So another trick is that I said on my plane, this is a plane. If you want to draw a plane with triangles, you will have to use 2 triangles. But actually in my game engine it's only 1 triangle, because what you can do is to repeat texture inside a plane. So here, if you do a large triangle, the actual screen will be the middle, the center of this triangle. To be very fair, the difference in terms of performance is not very impressive, because it's only from 2 triangles to 1 triangle. But I like to say that I succeed to divide by 2 the number of triangles you use in my game engine. So, last trick. The issue with the actual architecture is that everything is done in Kotlin in the CPU. And while everything is done in the CPU, the GPU is just doing nothing. What can I change? So there is still the color conversion, and before rendering it on the screen, I need to take a frame using all my color indexes and to generate a new frame, but this time with the actual color. And so everything is done in the CPU. For that, it's very easy. I just iterate over an array of color indexes. I get the new color, I create a new array, but this time with the actual color and this frame will be displayed on the screen. So the idea is to change a bit that. So this conversion is not done anymore in the CPU, but we will try to push this conversion into the GPU. To do that, I use a shader. It's a bit more complicated tricks if you're not to use shader. So the idea is that my array of color indexes, I will pass it to OpenGL as a texture. It's not going to be the final picture. But I will also pass another texture, this time with all the colors used in my game. The idea is that at the coordinates 1, in this picture, there will be the color of the color index 1. So what's doing this shader is that it will check on every pixel, it will get a pixel. It will get it from the image with the color indexes. So here I can get the color index. Then with this color index, I will check the other picture, and I will get the color that is in the color index position. So at the end, I get the final color and I can set the color. Like that, the GPU is doing more things than before. And it's still something that I can implement in different kind of shaders. So to sum up everything, actually Kotlin Multiplatform, for me it was a great experience. Everything is working very well. Just the Gradle setup that can be a bit complicated at the beginning, but otherwise it's working. I can run some code on any platform. If you want to do your own game engine, I think you should try first 2D instead of 3D. If you really want to do 3D engineering, obviously there is no issue to do it, but maybe if you are not fluent with matrices or other things like that, open a mathematics books before. The main issue for me, for my game engine, is the graphic layer. Actually, there is no common graphic layer, so you cannot use any graphic API. You need to implement it again. And as you can see, there is a lot of work done in the shaders. If for my next Christmas, if it's possible, I want to see a Kotlin multi-platform graphic layer in which you can, for example, describe a shader in Kotlin, in Lua, whatsoever, and it will generate everything for you, so you can use the same code with every graphic API. But to be fair, I think it's a lot of work. So it was the story behind my game engine Tiny. You can try it. You can check the source code on GitHub. Feel free to just look it and try it on your device. If this project is not appealing to you, there is other alternatives. For example, Korg, it's another game engine done with Kotlin Multiplatform. But you can also try another game engine like Little Kitty. It's a Kotlin Multiplatform game engine, and this time they're using WebGPU. Actually, what matters is not the game engine you're using, but that when you're doing games, when you're using this kind of game engine, just have fun to create games, to create game engine, and thanks to Kotlin Multiplatform, you will be able to run it on the JVM, on the web, or any mobile device. So, that's the end for my presentation. I hope you enjoy it. And if you have any question, feel free to ask to me after this session. Thanks.